If your team's trying to move faster with AI or scale more efficiently without reinventing the wheel, InfoQ Dev Summit Munich 2025, this October 15th and 16th, might help. It's a practical event, talks from people in the trenches, sharing what they've actually shipped, fixed, or learned. No big launches or buzzwords, just useful ideas you can take back to your team the next day. Learn more at devsummit.infoq.com.
Hello everybody, I'm Olimpiu Pop and I'm an InfoQ editor. And today I have in front of me Teena Idnani, the first keynote speaker from Dev Summit Munich and one of the speakers from this year QCon. And she did plenty amazing things, but without further ado, I'll have to ask Teena to introduce herself. Teena, please.
Yeah, hi Olimpiu. Thank you for having me. I am really delighted to be here. And as an introduction, I'm a senior solution architect at Microsoft. I help organizations with their digital transformation journey, helping them design scalable cloud-native architectures. Prior to joining Microsoft, I was at JPMorgan Chase, where I helped the bank with their Azure platform setup as part of their multi-cloud strategy. Beyond my day-to-day work, I'm quite passionate about quantum computing and its potential applications, particularly in finance. I also actively mentor aspiring technologists with a focus on supporting women in tech. And yeah, as you mentioned, I recently got this amazing opportunity to share some of the multi-cloud event-driven architecture insights at QCon 2025 that happened in April. And I'm very excited to discuss a little more on the topic here with you. But just before we dive in, I do want to mention that all thoughts and opinions that I'll be sharing today are my own and don't represent my employer views.
Okay, great. Thank you, Teena. So I was just thinking about your presentation at QCon, and you had that scary diagram, those boxes, and it was unbelievable. And then it's so fascinating that these days we are speaking, even in the bank ecosystem that was usually more traditional, about multi-cloud and different layers of services that you'll have, and probably you'll have on premises the important stuff that you don't want to go out, and then you have on different type of clouds, different services. And what are the key points that people should have in mind when looking into this kind of transformation, when you're discussing about multi-cloud in an ecosystem that complicated as the banking ecosystem?
Yeah, I think first let's just talk about, event-driven architecture, and then we'll add the multi-cloud to it, right? So basically, just at its core, right, event-driven architecture is nothing but a design paradigm where you have basically the production, detection, consumption, and even reaction to events. That's what drives the system. And I do remember the scary, complex diagram which I showed, in which there were hundreds of interconnected components which were distributed. And we're talking about that complexity. But essentially, event-driven is all about making these distributed components loosely coupled and making them react to the events. And that's how driving the system. So, for example, like if you take an e-commerce platform, now when a customer places an order, let's say it generates an order created event, and that event contains all the necessary information, the metadata information, maybe like the customer ID, the product details, shipping address, payment information. But here is where it gets interesting. That single action that the customer did to place the order, it basically triggers a cascade of other events. So for example, payment system generates a payment processed event, inventory system creates an inventory reserved event, and shipping system might generate maybe a shipping label created event. Now, each of these systems, they do not know each other directly. They're just reacting to events that they care about, which then means is that you can have hundreds and thousands of interconnected components, but you really don't have to worry about them when you're talking about event-driven, because the individual systems, they really do not need to know about others directly. They're just reacting to the events that they care about. So I think that's what simplifies it. And I think what makes these event-driven architectures really powerful is how they enable these loosely coupled systems, right? Unlike you talk about traditional request response patterns where services directly call each other, in an event-driven model, these components, they communicate by publishing events. So this event-driven approach, it offers a lot of advantages. And yeah, there are a lot of considerations as well that you need to take care. So first, if I just talk about the advantages, I think it provides that exceptional scalability because your components can be scaled independently. Talking about other advantages, it enhances the resilience. So for example, if one component fails, others can still continue operating. And most important, I think it enables that real-time responsiveness because your events are processed as they occur. Now, if you bring the multi-cloud flavor to it, what happens is that in a multi-cloud, then you are not just talking about different services which are there in a particular system, but now you are also talking about extending those services to different cloud providers. And I think that's when it then becomes really important to have some strategic considerations when the companies are doing these multi-cloud transformations. For example, if you're talking about the architecture and design, then you need to design for portability from the start. So maybe use containerization, use microservices. When you're building your APIs, it's really important that you're building cloud agnostic APIs so that you basically avoid a deep vendor lock-in. Data, it's really important when it is crossing the event boundaries. So you need to plan for data synchronization and consistency across clouds. And then I think the foundation of multi-cloud, right? The network. So you definitely need to think about your hybrid connectivity patterns and your network architecture across as well.
Okay, so let me see if I got it right. So more or less an event-driven architecture is based like more or less a domino system. You have the part that just gets started, you have an input, and then that cascades into multiple events, and they just go up to the point where they can. And then if something happens with a given system, you have that resilience that, let's say, the request is kept, and then when the system goes online, it will just start processing as well. Well, if that's the case, in some situations, it probably we can't afford doing that. And then, because I got ahead of myself and I just added multi-cloud to the conversation, in that particular case, you have to be careful on how you weave those in to make the things that are quite easy. So probably you'll have like IDs that are just represented and make sense from one side to another, even though they are not the IDs that you normally have in a database where you just link it, but just some, let's call it domain IDs or whatever. It will be the correct part. Great, thank you. Still, it's funny for me. I was just thinking while we were discussing topics the previous weeks. Now we are talking about that much about sovereign cloud, and then we are discussing now about how does those things get represented in this new ecosystem with multi-cloud, but also sovereign cloud, because that adds an extra level of complexity. The banking sector is probably one of the most regulated ones. How do you anticipate this extra headache will look like? So you have multi-cloud, and then you have the regulations, and then you have the new strive towards having your data contained in a place where you want to do it. Would it affect it or not?
Yeah, it will definitely affect it. And very rightly said, I think in financial organizations, it really becomes very important to take care of these data residency requirements as well, because of the strict compliance regulations that these financial organizations need to meet. But that's where I think multi-cloud also is like an advantage, because earlier when you were just in one particular cloud or maybe in a one particular on-premise system, you were relying on the capabilities that that provider was giving to you. And sometimes because of these data residency requirements, you really cannot access all the services that you ideally want to access. But this multi-cloud has actually expanded that service set for you. Like each cloud provider has such a big, vast suite of services which are available in different regions. So now kind of think like this. If you do not have a real vendor lock-in with a particular cloud provider, then you can actually choose the best service that you think would suit your particular scenario. And of course, meeting the data residency requirements and the sovereign requirements of your regulator that you're bounded to. But I would say it kind of makes it easier to deal with. A lot of these regulatory organizations question a lot on the concentration risk. So for example, if you're a very big fintech bank and you're only having all your workloads, let's say in just one cloud provider, let's say AWS for that example, then it actually becomes a concentration risk given what happens if that cloud provider goes down. So I think in specifically those cases, it becomes very important for these fintech banks to explore the multi-cloud services to also look at these concentration risks, that might get mitigated when you are having multi-cloud providers. So there are considerations when you are dealing with multi-cloud providers, specifically when it comes to these regulations, but there are also a lot of advantages around it.
Okay, well, obviously, where is an advantage, there is also disadvantage. And then we have the chance, we technologists, to just say it depends, and to make everybody just smile, hopefully. So did I hear you say that probably solutions that are, let's say, cloud native, because that will help you, or maybe not go there, to make the things agnostic, so not really depend on the services that are tailor-made for one of the cloud providers, will allow you to be sure that you have what it takes. So if I got it correctly, it would be better to just be able to use the cloud as just infrastructure, and then that's it. So more or less you have a container, and then the cloud is just the place where it resides, and you just make sure that the infrastructure is not under your desk but in the cloud. So more or less that should be the case.
Yeah, that's one way to look at it. Yeah, so definitely I will say it depends in this case. Like, yes, you're right. We can use containers and then use your cloud providers as your infrastructure setup. But if you really want to take advantage of the services that these cloud providers provide, then I think it also becomes important to look at the PaaS offerings of these cloud providers. So I would say, like it depends on use case to use case basis, whether you want to go for containerization and then using your cloud provider as an infrastructure provider, or you actually want to use these different platform as a service offerings that these cloud providers have to offer, because those PaaS services, right? So for example, if I just talk about Azure, we have Azure functions. Now, these Azure functions, if you can basically configure correctly, or if I talk about AWS, then the Lambda functions, then you can basically configure them and they can give you that scalability options. They can give you the different security configurations like identity management, authentication, authorization. So those are the kind of things that you automatically get, the redundancy options. So there are advantages. Definitely the interoperability will be difficult, but that is the trade-off, right? Do you want to reap the full benefits that these cloud providers can provide you by using their platform services, but ensuring that, yes, then you will require interoperability between the different services, between the different systems which are hosted in different cloud providers? Or, yes, you want to go with, let's say, each microservice that you have, you containerize it and then you host it on a particular cloud provider, and that's how then you start using it. So I would again say it depends on the use case to use case that you're dealing with.
Okay. But that beats the question. Okay, this is very complex, that's for sure. How do you stay on top of that? Because banks have also a very high SLA usually in terms of operation. That's the main question. How do you stay on top of that? There are a lot of solutions that are appearing in the cloud native ecosystem that are just taking main stage these days.
So see, my advice on those things is, of course, first, you need to upskill yourself and you need to be updated, especially with these new services which are being released by these cloud providers every day. It's definitely not easy. But I would want the organizations to basically invest in your team skills. And very rightly said, these multi-cloud systems, specifically event-driven architectures, they require a different way of thinking. Your developers, they need to understand, first of all, the concepts like what is eventual consistency, what is idempotency, distributed tracing. And then your operations team also need to be comfortable with multiple cloud platforms. So this is not just a technology transformation that we're talking here. It's also a skill transformation. So it's very important that the teams are staying upskilled on the latest cloud providers. It's also a very big mindset transformation to reap the benefits of cloud and seeing how you can use which service of which cloud provider, which will work really well in the specific use case that you're looking for. And then how do you build these well-architected systems, applications, and architectures. Yeah, not an easy job for sure, but that's what keeps us on our toes, right?
Yeah, that's true. So I was with QCon, and a lot of the folks there were talking about open telemetry and open observability and all the other stuff. As an architect, what are you recommending? What did you try, and what does it work in terms of observability?
Yeah, I definitely recommend open telemetry. So basically, what I usually advocate is like observability is where many multi-cloud initiatives succeed or fail. So observability is really very important, but at the same time, it's very challenging in multi-cloud environments because when your events are crossing multi-cloud boundaries, then the traditional monitoring approaches, they break down because you lose that end-to-end visibility. So to solve for that, I think what I recommend is first of all, standardize on an observability data model across all clouds, which means agreeing to common formats for tracing, for metrics, for logs, regardless of which cloud they originate from. And then I think, yes, I do recommend OpenTelemetry as a foundation for this standardization because OpenTelemetry basically provides vendor neutral APIs. So that's a very important bit here. And it provides that instrumentation to collect your telemetry data. This means that your application code, it instruments all the different events the same way, regardless of which cloud provider you're running it in. You're running it in AWS, you're running it in Azure, or maybe you're running it in GCP. And then that's one platform that you need to use. But for tracing specifically, what I have seen teams, which works for teams, is like implementing these correlation IDs that persist across different cloud boundaries. So each event will carry its unique ID, but it will also contain the full causality chain. So, which will allow them then to reconstruct the complete event journey, even if it is spanning multiple services across different cloud.
Okay.
So, and then, you have dashboards. At any given point in time, you do require that visualization tools and the dashboards because it's very important to create a unified observability platform that aggregates data from all cloud providers. In those cases, I usually prefer a cloud agnostic solution because you're dealing with multi-cloud. So using a cloud agnostic solution, maybe like Grafana or Elasticsearch, or you could even leverage one particular cloud's monitoring capabilities as like a central aggregation point and get the rest of the cloud providers to send all the traces and logs to that central aggregation point. But I think observability, when it comes, is really important to make sure that we get it right, especially in multi-cloud scenarios.
So, regardless of whether we're working in a single cloud environment where we have multiple services or we are working in a multi-cloud environment, the secret sauce is to remain consistent and harmonize the way how we are using. So in case of logs, always use the same standard so it makes sense and they look the same regardless of where the information is coming from, whether it's cloud A, cloud B, or our infrastructure under the desk. And then when you're discussing about tracing, given that you would like to have it properly organized and you have the full picture of everything, just make sure that the ID is moving from one call to another, regardless of the cloud boundary, to just allow the telemetry magic to show itself.
Yeah, exactly. I think you just nailed it. Absolutely. I think this is one of the most common mistake that I often see is, that need for that semantic consistency in your data. By that, I don't just mean that your data format should match. No, actually, the meaning behind those metrics, those error codes should be consistent as well. So absolutely, consistency is the key there.
Okay. And then the visualization is just the aggregator. If you did the first two right, the rest of it should be a charm because OpenTelemetry is a standard, and then everything as it was built on top of it will just take advantage of these benefits of having things consistently.
Right. And additionally, I think what is beneficial is rather than just having technical dashboards, right? Like instead of just showing your CPU utilization across different clouds, if you have these business process dashboards wherein you are showing things like how many orders got processed per minute, or maybe your average order processing time, or if you want to show maybe your orders which are stuck in processing. So that will be really a very good use of the dashboards and the visualization, because it will give your business stakeholders visibility into what's happening without really needing to understand the underlying technical complexity.
I like this because I see more people that are talking about user experience and the benefits that the end user are seeing. So the business side of the organization. So I really like that you touch on that, because it's a notch closer to the ideal situation where you're just delivering a service and you don't care about the underlying technology. So that would be the advice, that probably we'll have to keep in mind a domain boundary, let's say, when we are just putting from one side to another, and then think from the point of view of the domain. So rather than just saying that we want, I don't know, 5 orders per minute, we would like to say that the satisfaction for filling in that order is, I don't know, 20% or something like that. I don't know. It's Friday, so it's hard to come up with proper numbers. Nevertheless, event-driven architecture is not for the faint-hearted. So it's not something that you'll start off the bat, because, as you said, it's not a classical architecture like server-side that's quite simple to understand. Event-driven is probably, it requires a level of understanding of everything before you get started and to make things right. When you shouldn't use event-driven architecture, or what's the scale of your system, or the amount of events, or I don't know, what would be a proper heuristic to just make sure that you understand when you should look into event-driven architectures rather than overcomplicating your life?
Yeah, very, very well said. I think the first suggestion from my side would be like, if it's a very simple scenario that your application is dealing with, probably there's no need to over engineer, because event driven, it does require that mindset shift when you're building event driven systems, because right from the start of when you need to be brainstorming the events, you need to start thinking from a domain driven model, those kind of things, and then you need to make your way out. So it is complex, it is not easy. So in case if your application is really just something that can be done with a REST API communication, like simple linear workflow, maybe it has your straightforward CRUD operations without really any unpredictability, they're all very predictable, then I won't say you need to go for an event driven. If you have a simple request response pattern where just direct calls are sufficient, again, I will say stick to the direct request response pattern rather than building an event driven around it. If your application is a very small sized application with minimum integration requirements, you do not have a lot of integration boundaries, you're not talking to multiple different systems, you don't have like that need of loose coupling between the systems, then I would say, don't go for event driven. Or sometimes we have things which specially require batch processing. So event driven is more for real time things. So if you have to do something batch overnight, a batch processing job has to run, I don't see a reason why you need to be using an event driven for those kind of things. Other places where you should be thoughtful before using event driven is, what if your application has strong consistency requirements? Because you must have heard, even in the QCon conference, I did mention that you should be aware of what your consistency is. Is your application okay with eventual consistency? And consistency is not binary, it's a spectrum. So you need to see what consistency level can your application use. So if it is strong consistency, then I would recommend, like, for example, if it's a financial transaction which requires your asset properties across multiple operations, then event driven may not be the best use case. Or another example could be your real time inventory management, where your stock levels should be absolutely accurate. Otherwise, you're sending an order which doesn't really exist. So those kind of things, I think, they become more challenging when you're doing it in event driven. I'm not saying it's not possible to do event driven in those scenarios, but the debugging will become a little bit more challenging for such simple scenarios, right? You will see those observability challenges, you will see performance latency related issues, and then I think we talked about the skill set of the people. So you will have those team constraints, the organization constraints. You may sometimes also have data limitations. So, for example, if you have a highly sensitive data, then you really cannot save it in your queues. So those kind of things sometimes become a reason for you not to do this decoupling method of event driven and then just going for straight direct request response sort of mechanisms.
Okay, that's fair. In a lot of situations, as mentioned, I was discussing with Sam Newman the other days, and he was saying the following. If you really want, so pretty much that's why it jumped on my mind, pretty much as you're saying. If you have other options, don't go to event-driven. And he was saying the same thing. If you have other options, don't go to microservices. Start with the monolith and then break down pieces and go there. Can we apply the same heuristic here?
I won't say if you have other options and don't go for event driven. In fact, there are some anti-patterns that you should be avoiding for event driven. So, for example, do not use events for synchronous request response. Otherwise, you end up over-engineering simple problems with unnecessary event complexity. So those are the kind of things that you need to avoid. I still think that microservices is definitely a good pattern to go with. It's again a trade-off, right? Monolith versus microservices both have their trade-offs. With monolith, then you are too tightly coupled. Then you're not doing that loose coupling. So I would say it is required to use, but then you just need to be careful about certain anti-patterns where you should avoid using event-driven.
Fair enough. Thank you. I was just thinking, as you're discussing, you have the event storming and you're just thinking about your events, and then you have to consider them to be in a given domain. Would you think it would be useful to have more, I don't know, complex teams, and where you're just saying that you need to have people that really understand the business domain, where you have a horizontal cut through your company? Because what you're saying also before is that we should look at everything from the perspective of business. But usually techies are not that keen of. They care about 0 and 1, where, well, we'll not discuss about qubits these days because it's another conversation, but they don't care about these things. How do you make sure that those points are really tackled in a proper manner in these kind of systems?
So I think for event storming, right, it's very important that you're not just doing event storming with your technical people in the room. No, it's very important that you are doing event storming with the business analysts, with the product owners, right, who have the full knowledge about it. And then, yes, you should have tech in the same room as well, because tech should definitely hear about it. Like, I think gone are the days where tech would just take the requirement and then implement the requirement. I think it's very important to know the big picture. Why are we doing it? What business problem are we actually trying to solve by using technology? So it's very important that business needs to meet tech and vice versa. Tech needs to meet business. So in my opinion, when you're discussing these domain-driven designs, when you're talking about event storming, you are basically building how the user journey looks like. How will the customer, let's say, place an order? What events will be generated in that case? How will those events then be consumed by the different application systems and the different components? I think you need to start doing that from a business point of view, and then see how technology can help in achieving that outcome, the business outcome that we want.
Okay. In your experience up to now in designing systems, let's say event-driven systems, what are usually the customers looking for? I mean, as we discussed, you're discussing with business leaders or whatever, whoever are the business stakeholders. I bet that they are not coming to you and say, hey, Teena, I would like an event-driven system that does that for me. What they are actually looking for?
Yeah, they are looking for solutions to their problems. Let me give you one of my previous organizations example. So one of the organization I was working with, they were undergoing this digital transformation journey, and they had this requirement that one of the system that they were using was really not giving them the business value the transactions which were being processed on that system were really not very scalable. It was not giving them that right value add, and they were thinking of different options what to do with it. One way would be to deprecate that capability altogether, right? Like, do not use that and do not offer that to your customers again. The other would be, let's take a third party service which would do that for us. And then the last one would be, let us develop something internally, which then we can build from scratch, use the latest cloud native services so that we are taking care of those requirements, right? Like, not just the functional requirements, but also ensuring that we are building the applications as scalable, as performance oriented, and then they have the right resiliency and redundancy and different kind of options. So that's the problem they come to us with, that this is the challenge that we are seeing. How do you think you can help us, or what is the best way to move forward? And then in the example that I'm giving, we actually went with the third option. We decided that we would build a modern, digitally transformed application, API driven, but we'll build it in Azure. And then it was also having a lot of integration points with the other components which were already legacy and existing. And that's when then the whole strategy comes into picture, that you need to look at all the integration data points, how your new service is going to integrate with the others, which cloud provider is it going to be hosted on, and then what are the different data residency requirements and everything that come with it. But to start with, it all starts with a business problem. And then moving forward, how do you solve that business problem using the tech that we have?
Okay. It seems like problems taken from a manual, and that's quite nice. We are discussing about scalability, or discussing about resilience and also redundancy, because a lot, now the banks stuck on my mind, the banks have still old systems, decade-old systems at some point, but those systems are working as expected. But again, they need to have some boundaries. So then you need to integrate them with the modern stuff, because we would like to have banking on our phones. We want to have very fast banking wherever we are. So then this is the opportunity to do that. You just create probably a wrapper around the old systems. You create those boundaries. You just ensure that they react in the proper way. And then you push all those pieces together to just ensure that we are taking care also about the non-functional requirements or the legal requirements at some point. But as we are discussing about non-functional and discussing about data is very expensive these days, especially if it gets outside the boundaries of the companies. How should you treat, from the security point of view, event-driven architectures? How do they differ from the classical architectures, or if they differ in any way?
It would be different when you are talking with different cloud systems, right? So security would be like, you need to think about your data in transit. So how do you secure your data when it is in transit, right? So for example, you would want to encrypt all your event messages which are crossing the different boundaries using your TLS or SSL. And you would use your mutual TLS, you would apply the digital signatures. So I think, you would want to do similar things that you would do for your on-premise system as well, similar to your multi-cloud systems. Ultimately, you need to keep your data secure, right? And not just in transit, but also at rest. And I think that is where a lot of these database services, so if you're talking about the PaaS services which these cloud providers, they provide. So they provide you those encryption capabilities, whether it is at risk, whether it is at transit as well. And then it's very important for you to implement your key rotations. If you're having your storage account and then you have your access keys, then you need to ensure that you are doing those regular key rotations to ensure that we are keeping the data which is in these storage accounts kind of secure. So I would say that the considerations, data is important. You need to keep it secure, whether it is in your on-premise system, whether it is in your cloud systems. With cloud providers, like I mentioned, these providers, they do provide you with those services that can help you keep your data secure, but configuration is your responsibility. So security is like a shared responsibility between your cloud providers and between you. You can't just say that, hey, because I've hosted my data on a particular cloud provider, it is implicitly secure. No, it is your responsibility. Like the cloud providers will give you the right tools to make your data secure, but then the configuration responsibility lies with you.
What it just jumps in my mind now is like pretty much like your house. You have your house, but you have to take care of your windows and doors to be locked so that you're safe. But then whenever somebody's leaving your house, you're just making sure that you explain to them, be sure that you're crossing the road carefully, and then you're secure also in traffic. So yeah, fair enough.
No,
Thank
yeah,
you.
wonderful example, exactly, and I think it's also very important to have that network security. You gave me the example of house, and that's exactly when I remembered, right? The network perimeter. So you need to ensure that you're using the right private endpoints, you are avoiding that public internet exposure to your data. So absolutely, I think all of these things are very important when it comes to the security of your data.
Okay, cool. This was really insightful. So, was there anything else that I should have asked you about event-driven and multi-cloud that I didn't, but I should have?
No, I think you pretty much covered all. I think the considerations when you're dealing with event driven, specifically in case of multi-cloud. And then I think observability was one part that I was not really able to touch very well on my QCon presentation. As you have the time limitation, right? And I still think I had so much to cover. So yeah, I think you pretty much covered it all.
Okay. Thank you, Teena, for your time and for all the insights.
Thank you. It was a pleasure.